we're going to be talking about chasing your tail. I know that sounds like a funny topic for a programming class. Well, specifically, we're going to be talking about branching and looping. You see, not all programs can look like this one. At some point, we have to write a program that does something. Well, that's where branching and looping come in. But before we get to branching and looping, we have to talk about logical expressions. That's because both branches and loops use them to determine what to do next. I've put the Scratch and Java tiles, or statements, side by side. You can see that each of the Scratch logical expressions and each of the Java logical expressions come down to true or false. That's something important to know about logical expressions. They're Boolean. Boolean means that they equate to true or to false. Well, let's see how we'd use them in branching and looping. First, branching. So in Scratch, there are two different kinds of tiles that relate to branching and looping. The first is an if tile, and that corresponds, in fact, both of them correspond to the Java if-else statements. The if tile, if the logical expression is true, it results in two outcomes. Either it follows the positive or the true course, and in this case says, welcome to PRG 420, or if it's false, it just continues on. And in the if-else, if the logical expression is true, it says, welcome to PRG 420. If it's not, it says another message. And in both cases, then, it continues on. Something kind of interesting about both of these statements, in Scratch and Java, is that they can be nested. That means that you can have an if statement within an if statement, within an if statement, within an if statement. Now, you don't want to do that too much, or else it gets pretty hard to follow. The last statement I want to talk about is the switch statement. It's only available in Java. It only works with an integer or a character. But for each value listed, there can be a different outcome. It can be very powerful. Okay, now let's talk about looping. In Scratch, there are three basic loops. The first loop is this forever loop. Now, you could do that in Java too, but I'm not sure you would want to because it'll just run and run and run until you finally cancel the program. The second one is a repeat count loop. Now, that corresponds with the for loop in Java. And the reason why you'd use this loop is when you know how many times something's going to go through the loop, whether it's in Java or Scratch. That's the time to do it. The repeat until loop in Scratch corresponds with both the while and the do loop statements in Java. Now, you'd use this one if you don't know how many times it's going to go through the loop. You see, the logical expression is going to help us determine whether it finishes or continues to loop. The while loop in Java may not loop at all, because if the logical expression is never true, then it will never loop. However, in a do loop in Java, it will always loop at least once. But you don't see that exactly like that in Scratch. So that's looping. Well, now we're going to learn how to use these two branching and looping statements. We're going to do it with something called factorial. It's a mathematical expression. It is pretty magical, though. It's the product of all the positive numbers from 1 to a given number. For instance, 4 factorial, which is usually written 4 exclamation point, is equal to 24, because it's 1 times 2 times 3 times 4, or 24. Now let's see how we can use factorial in a program. Back to Scratch again. This time we're working with factorial. We're trying to create a formula for factorial. Well, like every time, let's start with our starting point. Now let's consider the variables we're going to need. So we learned that factorial was the sum, the product of the numbers from 1 to some maximum number that we specify. So using the illustration from the lecture, we had 1 times 2 times 3 times 4 for 4 factorial, or 24. So we're going to need some kind of let's create some variables. We're going to need some kind of a maximum number. Let's drag that guy up here, and we're going to set him to 4, just like we did in the lecture. Then we're going to need something that keeps track of which number we're on, from 1, 2, 3, and 4. Okay, so let's create that variable. We'll call it the current number, and we're going to set that guy equal to 1. And then we're going to need our answer. So let's create one called my answer. And we're going to set that guy equal to 1 also. We'd set him to 0, but when you multiply something by 0, it's always 0. So we don't want to do that. Okay, now we're going to need a loop, because we're going to use the loop to go through and do this as many times as we need. So in this case, we know how many times that we need to calculate, because it's the max number. So if we're going to do 4 factorial, we're going to go through the loop 4 times. So let's bring this repeat count tile out here, and we're going to say repeat max number, in this case 4. Okay. Now we're going to have to calculate within the repeat block. So first of all, let's set the current number. Our current number is already 1, so we don't have to do that. Let's set my answer equal to the product of my answer times the current number. Okay, and then let's set the current number. We need to add 1 to it. So we do that with the plus tile, and it equals current number plus 1. Okay, and then the last thing we need to do is, once we're all the way through the loop, we're going to say my answer. Okay, so let's just go through this again really quickly. When we start our program, we're going to set these variables initially. Max number is the number of times we're going to go through. So for example, 4 factorial. The current number is which one we're on, and that's going to start with 1 and then go to 2 and then go to 3 and then go to 4. The answer is the product, and it's going to accumulate as we multiply. We have our repeat block here, and we're using max number as the top number. So it's going to start at 1 and go to max number. Within here we have our 2 formulas. The first is to calculate my answer, and it's taking the product of my answer that's already been in there and then multiplying it by whatever the current number is. So it'll accumulate as the number increases. And then we're also going to set then current number by adding 1 to it. And at the end of the repeat block, we're going to say whatever the answer is. Well, let's check. Now, according to the lecture, the number should be 24. Let's click the flag, and there's 24. And if we change this maximum number to something else like 5, and we run it again, we get 120. There, that's correct. All right, well, we've seen how we can do factorial using Scratch. Well, we've done it with Scratch. Now let's use factorial, branching and looping, in Java and see how much it is the same. Well, we're back to Java, and we're working on factorial. Now, we already did a little example of factorial earlier in the class. So I've kind of blocked that out, and we're going to start again. In the first time we used factorial, we were just doing a simple calculation without a loop. Now, that's okay if you want to do it with small numbers, but what if you want to do 100 factorial? That's a really long calculation. So we're going to use a loop to make it easier. Okay, just like we talked about, again, factorial is the product of numbers from 1 to some top number. So the first number that we're going to need to deal with or create is a variable that manages max number. And for this illustration, we're going to set it to 4. The next one we're going to need is a current number variable that keeps track of which number, 1, 2, 3, or 4, we're on. We're going to start it out at 1. And the last is the answer. And we're going to just put that here as 1. We have to use 1 because if we use 0 and we multiply to it, it's always going to be 0. Well, that's not very good. All right. Now, we're going to be using a for loop here because we already know how many times we're going to be going through the loop. We usually use a for loop when that's the case. Let's look at the syntax of a for loop. The first thing is telling it where to start. And we declare a variable right inside of here. We'll call it count. And we're going to set it equal to 1. Okay. The next thing we're going to put in here is a logical expression to determine when we've reached the end of our for loop. And actually, when the for loop should continue. So what we're going to say, we're going to continue while current number, count, is less than or equal to max number. I put the equal to in there because we want to count 1, 2, 3, and 4. And then the last piece in here is adding to count. Okay, So I'm going to say count plus plus. And that means every time through, it count's going to start at 1, 2, 3, and 4. Okay. All right. Now within our for loop, which by the way, we need to put in a main here. That's why it gave us that little red reminding me that we need to do this. Okay. So within our for loop, the first thing we're going to do is we're going to calculate our answer. So my answer equals my answer times the current number. And then when we're done with that, we're going to increment or add 1 to my number, to the current number. We do that simply like this. All right. And then when we're all done with our loop, we're going to print the result. Now, if we've done this right, we should be able to run this program and see that we have the 24 as the result. I'm just clearing a few of these spaces out of here so it's more concise. All right, I'm going to right click and run. It's thinking, 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 and the answer is 24. Perfect. Now if we were to come up here and change max number to 5, rerun, we should come up with 120, and we do. So that's how we use a for loop to calculate factorial.